We've got our vocab down pat, so let's jump right in. We're going to do some actual hypothesis tests, but we're going to focus first here on the population proportion. All right? So let's do this. When observed results are unlikely under the assumption that the null hypothesis is true, we say the result is statistically significant and we reject the null hypothesis. Let's say that again. When observed results are unlikely, under the assumption that the null hypothesis is true, we say the result is statistically significant and we reject the null hypothesis, okay? So, observed results. So whenever I'm doing my data, if my data here that I'm looking at, okay, are unlikely under the assumption that this is true, the results statistically significant and we reject. So we're saying the information that we are given is unlikely. So we're saying this is unlikely that the null is true. That means we're going to change our mind, right? So then we reject the null hypothesis at that point. All right, and we're going to do this with what's called a p-value approach. So the p-value, let's define what that is, and then that's the approach that we're going to use to do these hypothesis tests. There's two methods to do this, the classical method and then the p-value approach. We're not going to worry about the classical method. We're going to focus on the p-value approach. All right, that's the most common one that's used. All right. So a p-value is the probability of observing a sample statistic as extreme or more extreme. Than one observed under the assumption that the statement in the null hypothesis is true. Put another way, the p-value is the likelihood. Oh, I didn't have, something went wonky. Let me try again. Kind of moved around on me there. Likelihood or probability that a sample will result in a statistic such as the one obtained if the null hypothesis is true. Let's say that again. So, a p-value is the probability of observing a sample statistic as extreme or more extreme, so big time, right? Than one observed under the assumption the statement in the null is true. Put another way, the p-value is likelihood or probability that a sample will result in a statistic as the one obtained if the null is true. All right, so we're looking at this and saying, what's the probability that we're going to be able to pull this off? Is this true? Is this not true? How is this hypothesis going to play out? And the p-value is going to pull that off. All right. So the lower the p-value, when we're looking at p-value, the lower the p-value, the stronger the evidence against the statement in the null hypothesis. All right. Okay. So here's our hypothesis test that we're going for. If the probability of getting a sample statistic as extreme or more extreme than one obtained is small under the assumption the statement in the hypothesis is true, we reject the null hypothesis. All right, so that's back to the lower the p-value, the stronger the evidence against a statement in the null. So if the probability of getting a sample statistic as extreme or more extreme, boom, then the one obtained is small under the assumption the statement of the hypothesis is true, then we reject the null. meaning we are changing our mind, right? Okay, so the p-value is how we're going to make that criteria to determine if we're going to reject or not reject the null hypothesis. Now, this little graphic right here is the setup of how we're going to pull this off. All right, step one, pardon me, determine the null and alternative hypotheses. Now, we've already been through this. Two-tailed, not equal. Left-tailed is less than, right-tailed is greater than. But the same for the null, right? We've already talked about that. The biggest thing is the alternative hypothesis, depending on what it is you're trying to talk about, depends on which test and which tail you're using. All right? Then, select a level of significance depending on the seriousness of making a type 1 error. A lot of times, alpha here is 0.05. Right? So 95% confidence, you have a 5% chance of making that type 1 error. All right? Then, continue with steps 3 through 5. So remember we said you do this level of significance prior to making your hypothesis and doing all the work that goes with it. So remember that we talked about that yesterday, that level of significance. So the first thing is you want to say, okay, what do I currently know and what do I want to do as an alternative? Then I throw down my level of significance. Now the problems we have are already going to have this set up for you. We're not creating a hypothesis test. We're just going with what we already have. All right. Then step 2, before we jump into the approach, this p-value approach is what we're doing. We're not doing the classical at all. Before we jump into this p-value approach over here, we have to determine these pieces to continue provided that. So this has to happen first. So we have to take effort to make this happen. The sample is obtained by simple random sampling or the data result in a randomized experiment. Then, have you seen this before? Yes, you have. It doesn't go away. It is still there. That's part of looking at it. Also, the sampled values are independent, meaning the sample size is less than 5% of the population. Remember this little fella? Yes. So we have to make these determinations. We have to set this up first before we even get started with it. So we make our statements, our null and alternative hypothesis statements. The level of significance is laid out for us. We have to hit these criteria. Then we jump into this. Now, we are not doing this by hand. We are actually starting here at step 3, because this is the by hand step 3 or the technology approach, which is what we're going to do with StatCrunch. All right. And that's how we're going to lay this out. So with that technology step 3, and then this is the real deal Holyfield right here. Once we get the p-value from StatCrunch, I'm going to make this a little bit bigger so we can see it. If the p-value is less than alpha, we reject the null hypothesis. Remember, what did I just say? The lower the p-value, the stronger the evidence against the null hypothesis. Okay, so the lower the p-value, the stronger the evidence is against the null, and that's why we reject it. If the p-value is greater than, then you do not reject, all right? But, I mean, that's common. I mean, that's obvious is what I mean. If you already know the p-value has to be less than alpha here to reject, well, then the opposite true means you do not reject. And it's not going to equal. That's not even an option available. It'll either be smaller than or it'll be greater than, right? Then we state our conclusion. So we practice stating the conclusion, right? If there is sufficient evidence, if there is not sufficient evidence, right? And then you go forward from there. That's what the conclusion is going to be that goes with it. All right. So this big graphic is there, but this whole piece is gone. This whole top part is gone. We're not messing with any of that stuff. We're jumping right here to Tech 3. We're going to use StatCrunch. Look at the p-value that goes with this and state our conclusion. So we are actually going to have this part of it, this part of it, this part of it, this part of it, and this part of it. Those are our 5 steps that we're looking at. Okay? All right. Well, let's get ready.